So, my name is Taylor Tucker, and I am the Reef Injury Prevention and Response Specialist here at the Office of Resilience and Coastal Protection. I mostly focus on finding ways to prevent anchor damage on reef and then responding to an anchor damage event and helping to restore the coral reef habitat. With me today, I have Jessica Price, who is also in the Reef Injury Prevention and Response program. Not sure if she wants to come on and say hello.
Hi, everyone. Thank you for joining us tonight. As Taylor said,
I think we may still be having a few technical difficulties, so we are going to move on to the next slide. So we have some other classes that have been going on during Earth Month this month, and that includes an introduction to Florida's coral reef, marine invertebrate identification, reef fish identification, stony coral identification. If you missed part one, you can go back and watch that at the link on the top of this slide. And then also we had some stuff about bleach watch training, where if you're a diver, we definitely want you to check that webinar out, and then you can learn how to get involved with our monitoring process for coral disease and bleaching. And also this webinar will be recorded as well, so if you want to come back to this one later, you can also do that. So just an overview on Florida's coral reef. DEP manages all the way from Martin County down to Miami-Dade County. We have 3 parallel reef tracts in the Kristen Jacobs Coral Reef Ecosystem Conservation Area, or we like to call it the Coral ECA. The 3rd or outer reef tract is our oldest and the only tract that extends into Palm Beach County. And the 1st and 2nd reefs peter out around the Broward County line or Hillsborough Inlet. So along Florida's coral reef, we have some key benthic community functional groups. We have octocorals, we have algae, sponges, and stony corals. Benthic or bottom dwelling communities are made up of many different species, and they range all the way from the tiny microbes all the way to the massive boulder corals, and they all play an integral role in this delicately balanced ecosystem. So before we had gone over fleshy corals and branching corals and also our scodemias, and then this time we're going to be focusing first on our brain corals. So within this, they have a mounding and massive morphology, a wide geographic and habitat range, and also they're what's contributing to a large portion of the reef biomass. So first up is the Boulder brain coral, or Colpophyllia natans. It grows the largest of all the brain corals, and the ridges are rounded and often differ in color than the valleys. So like you can see here, the ridges are a bit darker and the valleys are a bit lighter. The valleys are usually long and meandering, containing several polyps. So where you see the right arrow, right in that valley below the ridge, that would be a polyp there. And they have very narrow septa. So that's that teeth on the top. And they all are very interconnected polyp mouths, and they're separated by a thick septa. They're somewhat common in Southeast Florida, and you can find them at depth ranges from 2 feet to 175 feet if you're a deep diver. Their colony sizes can grow up to 7 feet, and they form large domes. They have rounded ridges and have a thin, distinct groove that runs along the top of the ridge and halfway down the ridge. Another shot from above. Next up, we have our symmetrical brain coral, or Pseudodiploria strigosa. They're narrow, rounded ridges, usually without a groove, but sometimes you can see a very fine line groove, particularly near the colony edge. They are different than Colpophyllia natan, and their color is often brown or tan, and sometimes can be green or bluish. So these guys grow at a depth from 3 to 130 feet, and they have a colony size of up to 6 feet. They form smoothly contoured plates to hemispherical domes. And you can see that here in this photo. So one looks more like a plate, one is more like a dome, and they have parallel ridges at the colony base. Next up, we have the knobby brain coral, or Pseudodiploria clivosa. This one is very different because you can see those knobs on the top of it, and those are always very apparent with this species. The ridges are even smaller and more narrow than the strigosa, and they're often tan, brown, or cream color, and occasionally bluish or greenish. They're somewhat common and not unusual, especially in the shallow habitat or nearshore ridge complex. You can find them from depths 3 feet to 135 feet. Their colony size grows up to 4 feet, and they also form hemispherical domes or encrust along the surface. They have narrow, sharp ridges without a groove, and they have numerous irregular knobs, like you can see in this photo. This is what it looks like a bit up close. And this is also the knobby brain coral. Knobs are very apparent on this photo. Next, we have the grooved brain coral, or Diploria labrynthiformis. They have deep polyp-bearing valleys that are separated by broad ridges with wide trough-like grooves. And it kind of looks like someone ran their finger through wet clay or butter. I always can tell that it's this species because it kind of looks like if you were to put your finger on the top of the coral and like smudge those valleys in. Not that we ever want to touch corals. And they're often a cream or ivory color and occasionally bluish. They are somewhat common, can also be found in the shallow habitats and nearshore ridge. They also grow to depths 3 feet to 135 feet. Their colony size grows up to 4 feet, and they form hemispherical domes. Like I said earlier, they have that deep groove on top of the ridge, forming what we would call, quote, a double ridge. Next is the maze coral, or Meandrina meandrites. They have pointed out septa, and they're perpendicular to the grooves and very obvious. They're usually a yellowish cream color, but can vary. And they're one of the first species to bleach when temps are warm, and also highly susceptible to stony coral tissue loss disease. They used to be pretty common, but not so much anymore. But I have been seeing a lot of recruits over the last several months, and annual monitoring data has also been showing high counts of recruits, so that's some good news. These guys grow from a depth from 2 feet to 240 feet. Their colony size grows up to 3 feet, and they also form hemispherical domes and flat plates, just like the other brain corals, and the ridges are separated by widely separated septa and a thin line at the top. This is a little bit more of a zoomed in version where you can really see those polyps sticking out in between the septa. And here is another shot when they can also have a very varied color. Next, we're going to be talking about our encrusting mound and boulder corals, and with only one exception, these corals all have star in the title due to the star shape of their polyps. And we're going to be going through 12 species. So this is the 10-ray star coral, or Madracis decactis. Each corallite has 10 septa and short knobby branches or lobes, and they can be a yellow, brown, purplish, or gray color. They grow from depths 5 feet to 130 feet. Their colony size grows up to 6 inches, so they're a bit smaller than the other corals we've just seen, and they're thinly encrusting colonies, often with tightly bunched lobes, like you can see here in this photo. And they also have very small protruding corallites. Like I said earlier, each corallite has 10 septa. If you want, you can count all of the septa on this coral, and then you'll see that there's 10, hence 10-ray star coral. This is our blushing star coral, or Stephanocoenia intersepta. When the polyps retract, a dark border around the corallite is going to appear, and then the rest of the colony can appear pale or blushing. and they can be found from depths 10 feet to 130 feet. Their colony size is around a ½ inch to 2½ inches, and they have smooth domes or boulders and occasionally can be encrusting. They have variable spaced corallites, and like I said earlier, when their polyps retract, you're going to see that dark border around them. This is our smooth star coral, or Solenastrea bournoni, and I have no idea why the common name for this is the smooth star coral because it is rarely ever smooth. It typically forms irregular lumpy domes, and the corallites are protruding. So if you missed it in the part 1 for identification, the corallites can either be concave, they can be flush, or they can be protruding. So these ones are going to be protruding, and they're also irregular in the amount that they protrude. Color is a really good cue for this species. It's always some shade of this mustard yellow, and this species is also very susceptible to stony coral tissue loss disease, although it can be seen growing in some of the most turbid of conditions. So these ones grow from 5 feet to 60 feet, so a little bit shallower of a coral. Their colony size is 4 to 18 inches. They also have irregular domes and protruding corallites, like I said earlier. This is our elliptical star coral, or Dichocoenia stokesi. It has oval protruding corallites that can become elongated and usually Y-shaped, like you see in this photo. They have distinct septal walls, and they're usually a tan, yellow, or brownish color. We saw a major decline in the species after the disease outbreak, and it's one of the most susceptible species. Their colonies can form domes or plates, and here's a close-up shot of their elliptical or circular corallites. This is our golfball coral, or Favia fragum. It truly does look like a golf ball in the water. They're very rare, and I've only ever seen a few in our area, and they are a tan, yellow, or brown color. Their corallites are also protruding, but less protruding than Dichocoenia stokesi, and they can also grow from 3 feet to 90 feet. They have a colony size of 1 to 2 inches, and the colonies form small domes. They occasionally encrust, but usually you'll see them in that dome format, and they're also going to have those protruding elliptical or circular corallites. So this is one of my favorite species of coral, the great star coral, or Montastrea cavernosa. I think the polyps kind of looks like Cheerios. They're easily identifiable, and they're very variable in color. They can occasionally fluoresce, especially the recruits. I've seen them a very hot pink color one time, and they are pretty common. Sometimes it can be difficult and to identify them, and you don't want to mistake them with Polyphylla, which is an encrusting zoanthid. So you want to really look closely at the polyps to compare. And you can often see the mouth, so like in this bottom photo of MCABs, which you will not see on Polyphylla. Polyphylla is also squishy. It has no skeleton, and a close look of open polyps would show differences in their mouths. They grow from a depth from 6 feet to 300 feet. Their colony size can grow up to 8 feet, like you can see in this photo. And the colonies form boulders or domes. So also just want to point out, you can see the difference between MCAB and Polyphylla on the top photo. And then they also have large protruding circular corallites, which is 1/4 to a ½ inch in diameter. This is the Mountainous star coral, or Orbicella faveolata. They grow in large, massive mounds and at greater depths in sheets with skirt-like edges. They're somewhat variable in color, and they can be tan, brown, or purple. Corallites of this species and the next two species look very similar and are almost visibly indistinguishable. So pay close attention to the whole colony morphology. So what you would look for in this species are golf ball sized lumps that usually run down the sides of the colony, like you can see in this photo. They're usually arranged in parallel vertical rows, and this is present even on smaller colonies, but identifying recruits is very challenging. The species is relatively common, and this is actually a photo of a 317-year-old colony off of Fort Lauderdale that was about 15 feet tall, although I cannot tell you whether it survived the disease outbreak, so let's hope that it did. This is what the polyps look like a little bit closer, and they're also going to be circular corallites that are about 1/8 of an inch in diameter. They can form those massive mounds, and the colonies can grow fairly large. This is our Lobed star coral, or Orbicella annularis. It grows in clusters of large, thick columns with enlarged dome-like tops, kind of resembling potatoes in a way. Their living tissue is restricted to the upper portions of the columns, and the color is almost always going to be this brown, tan, yellowish color. This species is relatively uncommon and can grow from depths 6 feet to 130 feet. Their colony size can grow up to 10 feet, and as you can see, their colonies are in clusters of those long, thick columns. Sometimes I also think it kind of looks like a bunch of ice cream cones, like you can see in this photo. And they're also going to have those small protruding circular corallites. This is our Boulder star coral, or Orbicella franksi. I think it kind of looks like a crunch bar in my opinion. It grows in clusters of large, thick columns with those dome-like tops. And they're one of the few colonies that I've seen be all brown. And they're often small clusters of zooxanthellae polyps or white areas. So this is not coral bleaching that you're seeing on it, they're just clusters. And the species is fairly uncommon. It grows from depths 6 feet to 130 feet, colony size up to 10 feet, and it grows in irregular mounds or in crusts with scattered lumps. And it's also going to have circular corallites 1/8 of an inch in diameter. So here is another shot of Orbicella franksi. And then here is a photo of all of the Orbicellas together. These species were reclassified into a different genus a few years ago after more genetic work indicated that they were more closely related to Orbicella. So on the top left, we have Orbicella annularis. In the middle at the bottom, we have Orbicella faveolata. And then on the top right, we have Orbicella franksi. This is the mustard hill coral, or Porites asteroides. Their color is often, or most often, this yellow mustard color, or it can also be a tan brown and sometimes bluish. This is one of the most common corals that we have here. It's surprisingly very resilient and found in many habitats. In shallow water, it's often seen encrusting, but deeper colonies can form lumpy domes. One of the defense mechanisms corals have against undesirable physical conditions is to excrete a mucus that particular matter will stick to, and then this mucus layer will then be sloughed off over time. So it's not uncommon to see this species in the process of sloughing off a mucus layer. It can grow from depths 3 feet to 160 feet. Its colony size grows up to 2 feet, and its colonies encrust or form lumpy domes. And it's going to have small, flush, circular corallites, so not protruding or concave. This is the massive starlit coral, or Pseudodiploria sidorea. It grows from depths 2 feet to 220 feet, and its colony size grows up to 6 feet. The color is most often this tan, brown, orange-ish color, and when the coral begins to bleach, what we call paling, it turns purple or blue. This is one of the most common corals we have here, and it's also very resilient. These colonies can grow very large, and they form encrusting or domes or boulders. And in Fort Lauderdale, back in 2011, we were doing coral surveys, and not sure if it's still there, but we have a couple 100-year-old coral, and this is a photo of it. Next, we have the lesser starlit coral, or Pseudodiploria radians. It can grow all the way from this top of the surface all the way down to 90 feet. and its color is most often a pale tan with darker corallites, and it looks very similar to Siderastrea siderea, but the corallites look a bit different. As you can see, the one on the left, they're a bit deeper. So they form flat encrusting plates, and they have those pitted corallites. Just want to give a special thanks for the use of images, materials, slides, and information out to NOVA, Paul Human, the Florida Reef Resilience Program, Broward County, Durham, and the Smithsonian Marine Station, and the Nature Conservancy. I think this slide may have gone around a little bit because we have a couple more corals to go through. So this is the start of our quiz, I believe. Sorry for the technical difficulties. We might be going back and forth a little bit. But if you guys want to put it in the chat or as a question, if anyone wants to guess the species of this coral. So this is going to be our Siderastrea siderea or massive starlet coral. I saw someone had the right answer in there. Next, we have our, oh, 1 second. Sorry, guys. Seems that the next slide is still loading. Okay, so this is our next quiz question. If you want to put into the question box what you think this coral is. Yeah, I had someone write in MCAV, so it's going to be our Montastrea cavernosa or Great Star Coral. Nice work. Okay, next quiz question. What do you guys think this one is? Yep, so this is going to be our mustard hill coral or Porites asteroides. Hint, you can tell by the color, it kind of looks like a mustardy color. Great, next quiz questions. I'll give you a hint. Sometimes it can blush. So this is going to be Stephanocoenia intersepta or our blushing star coral. Next up, try and guess what this one is. Give you guys another hint. It's the largest of the brain corals. Yeah, so this is going to be Colpophyllia natans or our Boulder brain coral. This is also a brain coral. Can you guys guess which one? Try and look at the top of it, it's going to have a specific name for what is on top. So this is going to be our knobby brain coral or Pseudodiploria clivosa. Okay. Here's the next one. Try and look at those coral lights. That will give you your answer. This is going to be our elliptical star coral or Dichocoenia stokesi. Here's the next quiz question. One hint, it's really fun to go through these types of things. Yeah, maze. So like a corn maze or a cornfield maze. So this is our maze coral or Meandrina meandrites. Next quiz question. Yeah, so I had one guess for smooth star coral and you are correct. Here's another brain coral. Hint, this is the one where I told you it kind of looks like you squish your finger down on top of it. This is going to be our grooved brain coral or Diploria labrynthiformis. And this is kind of a combo one. So there's 3 different species in this photo. Can you tell which one is which? Yeah, so I see one guess for Lobed. So Lobed star coral is going to be number 1 or Orbicella annularis. Can anyone guess what number 2 or 3 is? So number 2 is going to be our Mountainous star coral. And correct, number 3 is going to be the Boulder star coral. So nice work, everyone, for sending in your answers. And thank you so much for hanging in there with us today. I know we had some technical difficulties in the beginning. And make sure you go check out part 1 of Stony coral identification to learn how to identify all the other different corals along Florida's coral reef. So if you have any additional questions or wanted to reach out, feel free to contact me at taylor.tucker@floridadep.gov. So thank you guys so much, and I hope you have a great night.